now we have the announcements. So you gotta listen to the announcements, and then we're gonna talk.
On September 11th every year. It is on this date that the devastating incident of 9/11 took place, when an airplane collided with the famous Twin Towers and thousands of people lost their lives in the year 2001. Since then, this date is remembered and celebrated as Patriot Day in the United States of America. Let's take a moment to remember. Middle school, if you don't want what is in your sack or expensive snacks, please don't throw it away. There is a cardboard box on top of the microwave in which you can place extra items that have been unopened. As always, keep our school safe and open by wearing your mask, practicing social distancing, and washing your hands. Also, exit the building if the entrance is assigned to your grade level. The playground is closed after school, but Beacon Park is open. Please drop your white mask in the gray baskets provided by the exit doors. They will be washed and sanitized and ready for the use next week. High school. On the bottom of the announcements every day is a tiny URL in which you can sign up for lunch. Mr. Peters has also posted the QR code throughout the building so you can use that to sign up for your lunch. High school has cross country today at 3, volleyball at 4:30. Lunch is a favorite, cheese pizza, bread sticks with marinara, salad, milk. Please rise for the pledge of allegiance.
United States of America, and to the republic for which it stands, one nation, indivisible, with liberty and justice for all. So in the state of Oregon, 1 in 10 people have been evacuated from their home. 1 in 10. 10%. Actually, more than 10%, because they're at over 500,000 and the population's only 4.2 million. I don't know. Not a real high percentage because so many people live in places like San Francisco and Los Angeles and such. But actually, in Oregon, it's closer to 1 in 8 have been evacuated. And if you take away Portland, let's say Oregon 1 in 8. If you take away Portland, which is nearly a fourth of the state's population, then you have more, 500,000 out of roughly 3.2 million. So that's like 1 in 6 or 7 people outside of the big Portland metro area. Hi.
I need to take my computer to my computers because it's yelling at me that I need an administrator task.
What are you trying to do?
It's for the, I was just trying to put in the lunch thingy, but I can't do anything at the moment. It's for the program that he gave me.
Yeah, you can have questions on the homework at all?
21B is it.
Yeah, well, we're going to talk about it. So you decide what you want to do. You want to take it there, it's up to you, but I'm going to keep talking. So 27. So with 27, if you have the surface area of the can, you've got pi r squared, but you have 2 of those, and you have to add that to the circumference multiplied by the height. That's the surface area of the can. Now, they give us the radius is how much?
3.2.
3.2. So if they give the radius of 3.2, what are these? Centimeters. Then the diameter is going to be 6.4. And circumference is equal to pi times diameter. So we could revisit, look at it like this, and that's supposed to be an r. So now we have a radius and we have a diameter, and then we're down to the height. So is it 241 is equal to 2 pi 3.2 squared plus pi times 6.4 h. Now it's just an algebraic manipulation to figure out what the height is, because that's the question, isn't it? What's the height of the can? So could you get away with this one? Could you do it?
Yeah, I think so.
I think, I'll be honest with you, at this
Yeah.
stage of your life in math, this is how you should be able to do this one. You know you're gonna subtract that, right? Because it's plus this, and here's where your variable is. So you're gonna subtract this, and then you're gonna have to take the result and divide it by pi times 6.4. Can you see that far through it?
Yeah.
So if I subtracted 2 pi 3.2 squared from each side, this 0 cancels, you're left with pi times 6.4 times height being equal to this. 241 subtract 2 pi times 3.2 squared. No parentheses needed. I did that there to make it easier to read, but you could, you could say yes. But then, if you divide this by pi times 6.4, that all goes away. So you divide all of that times pi times 6.4. Then you're down to h. You might be able to do that and write that all out in one step. I don't know. But at this stage of the game, we should start looking at this line right here and seeing this is a term, this is a term. This term gets subtracted to leave this alone. So here it is subtracted. And that way you can just sit down with your calculator and crunch it all in one cool swoop. I would not go and try to do any of these intermediate calculations. Wait till the very, very end. And then just shove that in the calculator and go. Do the whole top here, hit equals, and then divide it by that. And then you'll have an estimate. Okay, so then 21b. So you have a function f of n.
I went through the entire thing, but what I got was 47/47, which equals 1, so
Oh.
I didn't know how that.
Is it n minus 2 and n plus, or n minus 1 and n plus 2?
Yeah.
Okay, and then you're supposed to find f of what?
You're supposed to see what, when fn equals 46/49, that's what you're supposed to find.
So if you have this, that's f of n? Or,
Yeah,
or,
f of n equals 46/49.
okay, so
Trying to
then,
figure out what n.
so you gotta figure out what n is. Oh,
And I came out with 47/47, which equals 1, meaning that n would be 1, but that doesn't work.
how did you get it?
You're just trying to find n.
Yeah, but how do you find it?
Inverse operation. Or you could just,
I just looked in the table.
you could just subtract 2 from 49 and
Oh, okay.
add 1 to 46.
All right, yeah.
That's 47.
Yeah, so you did in your head. Okay,
I
that's fine, but it's not what we're looking for. What did you do?
I did it, I flipped it so that I could figure out what it would have been in the beginning, so I did it so that it'd be n plus 1, and n minus 2 equals 46/49, and I came out with 47/47, which is 1, which doesn't make sense. So I don't know what I did wrong.
Okay. This is a trick. You need to remember this one. We don't do these in our head. And we don't do these on the graphing calculator or something like that, or Desmos and use a table or something. We need to solve this algebraically. And here's the algebraic trick. When you have a variable top and bottom like this, and you have two fractions that are said to be equal to one another, you cross multiply. 46 times n plus 2 is equal to 49 times n minus 1. Two fractions are equal to one another, then their cross products are also equal. So you solve it like you solve a ratio or a proportion. This is a critical little trick that you'll be tested on again and again and again, being able to solve a problem like this. So then you have 46 plus 92, oops, that's ends, and then you have 49 ends minus 49, and now you can combine like terms and go and find out what n is equal to. So let's see what we're going to do. Subtract 46n, and then I'm going to add 49. Add 49. That 0 cancels. This is 141, and that's 3n. And then we divide.
Isn't it 47?
How much?
Isn't it 47?
47. Yep. That's how it comes out.
So then I sort of got the right answer. I just took it the opposite way.
This one, this whole problem is how you do it. And that's how you do these. They'll come up time and time again. Very powerful little tool that product is. So yeah, so that ends up being 47 minus 1 is 46, and 47 plus 2 is 49. No other solutions. There's only one solution. Because it's a linear function. You know, this is the function right here. 3n is equal to 141. So it's just graphs like that. So there's only one solution. You may look at it and think, oh, well, if it's a fraction, I might be able to have bigger and bigger values of n that work, but it doesn't work that way. Okay. Then, any others? Anything at all? For sure, for sure? Now is like your golden time to ask. Okay. Rewriting formulas, 1-7. So lesson 1-7 is all about taking a formula and manipulating it so that you are writing it for a different variable than it's originally written for. You know, so like area is equal to length times width. Well, what's width equal to? So this is 1-7. So if area is equal to length times width, what's width? Width.
Length divided by 80.
Well, I divide by L, right? So it's area divided by length.
Oh.
So there's taking a formula and just rewriting it using inverse operations. So you've been using inverse operations a lot, but usually with numbers. So now what we need to do is recognize that the same rules apply and the same order of doing things applies. And now we just, it might look a little more complicated because we don't get to simplify in between and combine integers or decimal numbers and fractions and stuff. So it gets a little messier. So we just gotta be careful to write everything out line by line. So let's see. You know, they say, just in case, as an engineer, they're so catchy. This book, it gets catchier and catchier with all the names, that's pretty cool. Just in case, as an engineer for a barrel manufacturing company. He wants to design a cylindrical barrel containing 500,000 cubic centimeters of liquid and is considering several different radii and heights. To do this, it is useful to solve the volume formula for height in terms of R. So the volume is pi r squared h. That's the volume of a cylinder. or of a cylinder. That's quite an angle. Is that in your way, Natalie? A little bit, not much. Can you live with it? Okay. So we need to solve the formula for H. So for H in terms of V and R. So that when we say that, that means H is going to be equal to all the other parts of the equation. So when we're done, it's going to look like this. So how do we get H alone? Using inverse operations. Get rid of the pi r squared, and the pi r squared is being multiplied by H, so divide, yeah. Divide both sides. Pi and r squared cancel. So this is what we have. So I'm going to flip it around. H is equal to volume divided by pi r squared. So it just makes it real handy to shove numbers in and get answers out for the height. And that's the purpose behind this. So the height of the barrel with a radius of 30 that will contain 500,000 cubic centimeters. Now we have this 500,000. And then we have this 30. And when we substitute them in, it makes it so that our formula has numbers that have all been substituted in on one side of the equal sign, we're left with only H. Whereas if we did that up here, we put 500,000 in, we put 30 squared here, then we'd be doing the inverse operations with the numbers in place. So the idea behind this is, I guess the usefulness is that you could now do many calculations in your graphing calculator, for example, very, very quickly, using the lists, for example. So let's, you crunch that out and get the numbers. That I'm not concerned with. When we start seeing fraction bars and things like that, it gets a little messier, though. So here we have this formula. And they say that this computes the number C of hours needed for one car driving R miles per hour to catch up to another car that is T hours ahead. So you hop in a car and you take off and somebody's going to catch up to you on the road. And you've got, a certain number of hours head start. And if they're driving 65 miles an hour, this is the formula that will determine how long it takes to catch up. And then, if you're going 65, you'll never catch up, right? To somebody else that's going 65. So that's why 65 subtract 65 in the denominator position is 0. There's no solution to this when we divide by 0. So we're going to first of all solve the formula for T in terms of C and R. So that means we want T equals when we're done. So what's the first step to get T out of the numerator position? Multiplied by the reciprocal of what?
No. Sorry.
So we want to get at least this far, right? So we have 65T divided by R minus 65.
So multiply by R minus 65.
Right, you can multiply both sides by R minus 65. And when we do that, we have to be careful to make sure we multiply by R minus 65 as a quantity, not just part of it. And then if we do that over here, and we think of that as a quantity, think of this as a quantity, then they cancel one another. So now you have R minus 65C is equal to 65T. So what are you going to have to do? Divide. So I'm just going to write this out. So now we're gonna divide by 65, divide by 65, and then we have t is equal to this. So there's a 65 here, there's a 65 there. We might simplify further, we might leave it just like that. It's a little bit of that is up to you. But if we simplified further, then we would have r times c, and then we would have minus 65c, and that would be over 65. But what I'm going to do is I'm going to write over 65 for each term, because then we can cancel that. And then we'll have RC over 65 minus C. Maybe it makes it look a little neater and cleaner, that's all. Yes?
Can you, on the left side of the equal sign, can you cancel the C's, or does that?
No, if it was C minus C, the only way you could cancel out the C's is if you were able to factor something out.
Okay.
You know, there is a way to factor out. If you want to factor out a C from each of these, this is C times 1, and this is C times R over 65. So this thing could be written like this as C over, or C times R over 65 minus 1. You could do this. You guys understand what I did with this here?
Yeah.
C is a common factor, because we have, this could be rewritten as C times R over 65, and this could be written as C times 1. So you pull out your common factor, and then you have R over 65 minus 1. Some people might think this looks nicer. So yeah, algebraic manipulation, that's a big chunk of what we're going to learn how to do this year. Got to get good at it, because it doesn't get any easier as we start trying to apply math to more complicated things. Okay, volume, here's the next one. Volume again, pi r squared h. So we're going to take this one and we're going to solve it for r. So now when we're done, it has to be r equals. And it's a little bit different because we're going to see something with an exponent that's got to be taken out, right? So it's all multiplication, so if we just divide by pi times h, we can get our r squared alone. But then to go from r squared to simply r, what has to be done? Square root. So we take the square root and we take the square root of the whole thing. And that's really where you end up. So it's not too bad. Next step, though, a little bit different. I think I want to write up here. If we were to continue on with this, and we knew that the volume was fixed at 500,000 cubic centimeters, like what was given earlier in example 1. If we put the 500,000 here,
And the 30 in
yeah, well, not the 30 in the R. If we do this right here, what might be done with this is radius is now equal to the square root of 500,000 divided by pi times h. That's what, or divided by the square root of pi times h. So they ask us in the second part of this example here, if we assume the fixed volume, write the formula for R in terms of h only. So what they want is they want you to have all of the values in place. And then this becomes the only variable. So I'm trying to look at this one and see why they did what they did.
So where it says R equals the square root of volume divided by h over the square root of pi, how does that work? How can that also be equal to the square root of pi when the square root of h, or the square root of volume over?
Yeah, so how do they get volume over h in the radical?
Yeah.
Over the square root? Okay, let's look at this over here. So this is equal to volume divided by pi h. So then we could look at this as volume multiplied by 1 over pi. Let's do, wait, hold on, yeah. 1 over pi times 1 over h. And that would still be underneath the radicand symbol.
Oh, I see, and then when you multiply volume by the h, it would go to the top.
Wait, hold on, what am I doing? This is incorrect. Division by pi would be like multiplying by the reciprocal of pi. And the reciprocal of pi is 1 over pi. And the reciprocal of h is 1 over h. So that's all that this is here. So that's written with multiplication. So what we could do is we could think of this and volume as being multiplied together. And if we just pick those two and put them together, then we would have volume over h. And then that would be multiplied by 1 over pi. And then we can kind of go backwards and we can say, well, multiplying by 1 over pi is like dividing by the reciprocal. So the reciprocal of this is pi. Therefore, you could have volume over h, all divided by pi. And then if we used the properties, it's the square root of the volume divided by h, divided by the square root of pi. And that's still equal to r. So it's a sloppy mess. I don't know how important that is. But that's what it would be. That's how they got what they have there. And so I wouldn't get too hung up on that one. No great loss if you don't follow that to the very end. That's just exercising more algebraic manipulation than what is probably necessary. So, let me give you a quiz, let you get started on that right away. It's only on the first 3 chapters, or I'm sorry, lessons, first 3 lessons, and we're all the way to 7 now. You can use anything except for your book. Notes, homework, of course, the calculator. look, hold on, look at the thing. Did I give you Algebra 2 or Geometry? This is Geometry?
Yes.
Shoot. What the heck did I do with Algebra 2? Oh, my bad, yeah. Okay, we'll try this again. You take your time and fall asleep, right, Logan? Logan, who's sleeping? He is sleeping. What? He's just acting like he's sleeping. Okay, here we go. You good now? You want a scratch paper? Yeah, I do. You want it with lines or grid or anything?
Just
Just lines. One, two, three. You want it? You would rather do your work on those two,